Okay, this is exam 1 for Physics 102, spring 2012. Which of these statements is true about charging by induction? Causes a bigger charge than by conduction. That's not true, or not necessarily true. Does not require contact between two charged objects. That's induction by definition, that they don't actually touch. So the answer is B. Let's look at these others. It cannot be done to conductors. That's not true. The wire that we had in class that moved when we brought the charged object up to it, that was a charge by induction, but it was on a conductor, so it can't happen with conductors. It can only occur with protons. That's usually not true, in fact. That usually charges occur with electrons, that you don't move protons around. What is the magnitude of the force acting on charge Q2? Alright, we have three charges with two forces acting on Q2. We have a force to the left, that's the force on particle 2 due to particle 1. And then we have the force on particle 2 due to particle 3. And then we want to take the net force, F23, minus F21. So let's write that out. Remember, F is from Coulomb's law. That's KQQ over R squared. So that's K F23 is going to be Q2 times Q3. I'm just going to leave them in microcoulombs, and you'll see why in just a second. Times 4. Actually, no, let's not. Let's go ahead and do it like we're supposed to do it. But it turns out to not matter. So I'm going to have 1 times 10 to the minus 6 times 4 times 10 to the minus 6. That's divided by the distance between them squared, which is 2 squared, so that's 4. Minus F21, which is going to be K times 1 times 10 to the minus 6 times 1 times 10 to the minus 6 divided by 1 squared. Now I get this 4 right here cancels with that 4, and the 1 just goes away, so I get K times 10 to the negative 12 minus K times 10 to the minus 12, so the net force then is 0. The right answer is D. Alright, what is the direction of the force acting on Q2? Alright, well, this is a positive Q1, negative Q2, so the force is acting in this direction. Let's figure out what this angle is. Theta is the inverse tan of 4 over 3, so that's 53 degrees. That's going to be 53 degrees from the negative x-axis. Let's see, 53 is here, but it's from the positive x-axis, so that's not right. So let's try, what is this angle then? That's 180 minus 53, and that's equal to 127 degrees from the positive x-axis, so the answer is A. What is the magnitude of the force acting on Q1? Alright, so that's going to be KQQ over R squared. That's 9 times 10 to the 9th times 2 times 10 to the minus 4 times, what's that, 3 times 10 to the minus 5 divided by the distance, which is 5 meters squared. This distance right here is 5 meters. You can use the Pythagorean theorem to find that. The square root of 3 squared plus 4 squared is equal to 5. Or you can just recognize that it's a 3, 4, 5 triangle, a special triangle. Alright, and that's equal to, let's see, the 10 to the 9th cancels with that and that. That's 18 times 3, which is what, 54 over 25. And that's about 2. So it must be 2.2. Number 4 is A. What is the magnitude of the electric field at the position of Q2? Well, we know that, well, a couple ways we can do this. Let's just do it this way. The electric field is KQ over R squared, where Q is Q1. So that's going to be 9 times 10 to the 9th times Q1, which is 2 times 10 to the minus 4, all over 5 squared. What does that give us? That gives us 72,000. So the answer is C for number 5. Look at this kid. What is her problem? Her hair's all standing on end. That means she has a lot of negative charges. So she just slid down the slide or whatever, and she picked up an excess of negative charges, and those negative charges have all gone to her head, and they've caused her hair to basically try to get away from one another, that they're all repelling one another, so that's why they stand up. So she has an excess of negative charges in her head. Many of you put B, that all the negative charges on her head have moved to the ends of her hair. No, that's not really true. That she actually picked up an excess of negative charge. So it's not that the charges that were already there have moved to the ends of her hair. Alright, a charged particle is, because, you know, if that was the case, let's just go back to that. So if that was the case and you just had negative charges just on the outer edges of her hair, then you would have positive charges down by her head, and then they would be attracted to one another, so it wouldn't stand up at all. Our charged particle sits in an electric field as shown here. If the particle moves in the direction of the dashed line to the left, what is the charge of the particle? Or will positive particles feel a force in the direction of the electric field? So this must be a negative particle, so the answer is B. The following figure shows equal potential lines for a configuration of charges. Which charge has the greater magnitude? Are you looking at the numbers here? So here I have a really big potential, and here I have a really small potential. Remember, potential is KQ over R. So this must be the biggest charge because it has the bigger potential. So that would be B for number 8. The following is a plot of potential versus position. You release a proton at x equal A. What will the particle do? So a proton wants to move from high to low potential. Alright, so here it wants to move from high to low. That's going to be to the left, D. So we can imagine that moving from high to low. Look, we have a small negative number and it's moving to a bigger negative number. So that would be like the proton being here at 20.8 and then moving excuse me, I'm sorry. It would be like it being here at 1.7, that's this point right here, and then moving in this direction so that the voltage increases in the negative direction. Anyway, it moves from high to low, so that's going to be to the left, D. What is the equivalent capacitance of this circuit? First we want to break these down. 1 over 3 plus 1 over 6, of course, is 2 microfarads, and that gives us a 2, a 1, and a 2, so that's 2 plus 1 plus 2. It's 5 microfarads, so number 10 is C. Previous question, what is the voltage across the 6 microfarad capacitor? Alright, we have to find the charge across the equivalent of these two. Now I know that the voltage across these two is equal to 12 volts. That means that the charge across both of those capacitors is 2 times 12, which is 24 microcoulombs. 24 microcoulombs. So each of those has 24 microcoulombs. So the voltage V2 is Q over C. That's Q2 over C2, which is 24 over 6. Which is 4 volts. So number 11 is C. Previous circuit, what is the charge across C4, the 2 microfarad capacitor? So I want to know what is the charge across here. I know that it has 12 volts because it's in parallel with the battery and these other capacitors, and so the charge is just going to be C times V. That is 2 microfarads times 12 volts, 24 microcoulombs. That's A. What is the potential in an electric field at a point P, which is in the center of this square? Alright, we have 3 positive charges and 1 negative charge. So I know that, oops, sorry about that. So I know that my potential is not equal to 0. Alright, now I want to find out my electric field. So let's take this charge first. The electric field due to that charge is in that direction. The electric field due to this charge is in that direction. The electric field due to this charge is in that direction. And the electric field due to this charge is in that direction. So the electric field is also not equal to 0. So that is option A for 13. What is the voltage across the 2 microfarad capacitors, C1? Alright, well, these two capacitors combine to give me 6 microfarads. So my circuit will look like this. I have a 6 microfarad in series with a 6 microfarad. 6 microfarads, 6 microfarads. Those are identical, so they split that 12 volts. So they both get 6 volts. So they each have 6 volts. Now remember, this is my C13. This is my equivalent capacitance. And it's equal to 6 volts. Or excuse me, 6 microfarads. And it's comprised of 2 capacitors in parallel. Capacitors in parallel have the same voltage. So that means that this capacitor and this capacitor both have 6 volts. And I was looking for C1, so the answer is A, 6 volts. Number 14 is A. If you charge a capacitor with a battery of 10 volts, then you remove the battery so the charge remains constant, then you double the distance between the plates of the capacitor. What is the new voltage across the capacitor? I know that Q is equal to CV. I also know that C is equal to epsilon naught A over D. I am doubling the distance, so I'm making this twice. That means that my capacitance is going down by a factor of a half. And so if my capacitance goes down by a factor of a half, keeping my charge constant, that means that my voltage has to go up by a factor of 2. The voltage was initially 10, so now it's 20. That's B for 15. What is the primary purpose of a capacitor? The primary purpose of a capacitor is to store electrical energy. It's not to create a current. A capacitor doesn't create current. It's not to create a potential difference either. It can do that in special cases, but that's not its primary purpose. It doesn't complete a circuit at all because the two plates don't touch, and the purpose is to store electrical energy. What is the potential at a cross? Marked with the letter P. Alright, right here. I know that, first of all, I know that this distance is 5 meters because it's a special triangle, and then I just add up the voltages, V1 plus V2. V1 is going to be K times 5 nanocoulombs. Let me write in the number. I'll just write in the numbers here. It's going to be 9 times 10 to the 9th times 5 nanocoulombs. That's 5 times 10 to the minus 9. Coulombs over R. Let's see, that was Q1, so R is 5 meters plus 9 times 10 to the 9th times 4 nanocoulombs, which is actually negative 4, times 10 to the minus 9 coulombs, divided by 4 meters. My 4's cancel, my 5's cancel, my 9's cancel there and there and there and there, so I get 9 minus 9. That's equal to 0. So the answer is D for 17. For 17 is D. Previous question, how much work is required to assemble the two charges? Alright, well, the work required to bring in the first charge is equal to 0. Alright, and then I want to know how much work is required to bring in this charge. It's equal to Q times V. That is negative 4 times 10 to the minus 9 coulombs times the voltage due to the first charge. That's 9 times 10 to the 9th times 5 times 10 to the minus 9 divided by R, which is 3 meters. Now let's see, that gives me smallish number. Was it C for number 18? Yeah, so the answer is C. If I do that, it gives me negative 6 times 10 to the minus 8. It's the charge times the change in voltage, and the change in voltage arises because of the second charge. You wish to measure the potential difference across a resistor. How do you hook up the device? Voltmeters are always hooked up in parallel, so the answer is A. Your hairdryer has a power of 1,000 watts. It operates 120 volts. How much charge passes through the wire in 1 minute? First, we need to find the current. Current is power over voltage. That's 1,000 watts over 120 volts. You get 8.3 amps. Alright, and then I want to find the charge. The definition of I is Q over T, charge over time. So Q is equal to I times T, which is 8.3 amps. An amp is a coulomb per second, so we need to change our time into the SI unit, which is seconds. So 60 seconds, 8 times 60, so 500. Yeah, 500. So the answer is D. Alright. Which has a bigger resistance, a hairdryer or a light bulb? The light bulb has less power, so that means that fewer charges are going through it. So it's harder to push electrons through the light bulb, so it has a bigger resistance. So the answer is B. Or if you want to look at it from math, so the light bulb is brighter, so there are fewer electrons going through it, so it has a bigger resistance. Or you can say that P is equal to V squared over R. The one with the bigger resistance has the smaller power. Alright, just mathematically that's how it works out. So the one with the bigger resistance has the smaller power, so the light bulb has the smaller power. Alright, consider the circuit. What is the current? Alright, V is IR, so I is equal to V over R. It's 24 over 2. That's 12 amps. So 22 is D. Rate for electricity charged by Entergy is 5 cents per kilowatt hour. This seems really low to me. 5 cents per kilowatt hour? I think it's more like 15 or 20 cents, but I found this number on the internet. So anyway, 5 cents per kilowatt hour. How much does it cost to run a 1,000-watt electric heater for 2 hours? Alright, you have to just say, I have 5 cents per kilowatt hour times 1,000 watts, which is 1 kilowatt, times 2 hours. My hours cancel, my kilowatts cancel, and I'm just left with money. So it's 5 cents times 2, that's 10 cents. I think it costs quite a bit more than that, though, for 2 hours. Which of these best describes an ammeter? An ammeter has a very small resistance, that's D. And then this is A. There are all the answers.